Hey guys, and welcome back. Let's go ahead and set up the load balancer for our Kubernetes master nodes in this video. So I'm going to head over to my AWS Management Console here, and I'm going to head down to load balancers here, and we're going to create a new load balancer. Now, Amazon Web Services provides a few different types of load balancers. There's a layer 7 application load balancer, there's a gateway load balancer, and then there's also a layer 4 network load balancer. And in this particular case, we want to create a layer 4 network load balancer. I'm going to go ahead and just choose that option in the console here, and then I need to give my load balancer a name. So I'll call this CBT Nuggets-Kubernetes, or maybe just K8S for short. I'm going to leave it as internet facing for now, and I'm just going to leave it as IPv4. So we're not going to enable IPv6 dual stack capabilities for now. And then you can also choose subnet mappings for your load balancer. And so I'm going to go ahead and just enable it for all of the availability zones in the US West 2 Oregon region here. So I've got US West 2A, 2B, 2C, as well as 2D. And then down here, we have the ability to create a listener. And the listener is going to basically serve as the endpoint that we communicate with using the utilities like kubectl, for example. And by default, the Kubernetes cluster API server is going to listen on port 6443. So we're actually going to expose on the load balancer itself, we're going to expose TCP 6443. And then we're going to forward that traffic to what's known as a target group on our EC2 instances running the Kubernetes service. So I'm going to go ahead and create a new target group here. I'm going to choose the instances target type here, and I'm going to call this CBT K8S as the target group name. Of course, you can name that whatever you want to. However, the target port that we're going to forward traffic to is actually going to be TCP 6443. So I need to make sure that I plug that port in here. And then down here under my health checks, I'm going to go ahead and just choose a 10-second interval here and choose a healthy threshold of 2. And that'll help just to ensure that the health checks operate a little bit more quickly here. So I'm going to go ahead and hit next, and then we're going to register both of our nodes here with the target group, and that will allow us to forward traffic from the load balancer to both CBT Master 1 and CBT Master 2. So once we've created that target group, I'm going to just close that tab, and then we'll come back to our load balancer creation screen. We'll just do a quick refresh, and then we'll choose that target group for our load balancer here. So our load balancer is going to listen on TCP 6443, and it's going to forward traffic to TCP 6443 on both of our master nodes, even though we haven't yet actually set up the master nodes themselves. So we'll hit create load balancer, and that'll take a couple of minutes to create, but now we can go ahead and initialize our cluster. So to do that, we're going to go ahead and use the kubeadm utility to initialize our cluster. And one of the parameters that we're going to need to specify is the control plane endpoint. So when you're initializing a new cluster and you've created a load balancer for it, the load balancer is going to have a DNS name and a port that you want to connect to. And we need to make sure that we plug that in so that Kubernetes knows how to communicate with the API server endpoint. So we're going to copy this command here to our clipboard, and we'll bring it over into our terminal here. And I need to make sure I'm on CBT Master 01. And we'll go ahead and paste that in, but before we run that, we are going to replace this load balancer DNS and load balancer port with the necessary values from our load balancer. So once the load balancer has been created, you'll have a DNS name right down here. We'll copy that to our clipboard and then paste that in, and we'll plug in 6443 as the port afterwards, and we'll go ahead and just run this command in order to initialize our brand new cluster. All right, so now our cluster has been initialized, and you'll see that we get back a couple of commands here that we can use to join other nodes to our cluster. But before we do that, let's take a look at the load balancer over here in the AWS Management Console. And if we drill into the load balancer itself and then maybe take a look at the target group right down here, our target group is named CBT K8S. And if we go over to targets, then you'll see that CBT Master 01 is in a healthy state, whereas CBT Master 02 is in an unhealthy state. And that's happening because we have the API server installed on port 6443 on CBT Master 01. However, we have not yet initialized CBT Master 02 as a node in our cluster. And so therefore, because it is not listening on 6443, the CBT Master 02 node is being treated as unhealthy. So eventually that will change once we install the master node onto that second node, but for now we just have the one CBT Master 01 as being healthy. So one of the things that we need to do is to copy our kubeconfig. So by default, the etc kubernetes /admin.conf file contains our kubeconfig file. And so what we want to do is run these commands right here to copy that into our home directory so that we can use kubectl in order to connect to the cluster. So if I was to run kubectl version right now, you would see that right now we are not able to connect to our Kubernetes server because we don't have that config file in the right place. But if I paste in these commands here and then rerun the kubectl version command, you can see that we are now able to successfully connect to our cluster. So we're actually connecting to the load balancer. So if I was to cat the .kube/config file here and just scroll up a little bit here, you'll see that our server endpoint that we're actually connecting to is an elastic load balancer rather than connecting directly to an EC2 instance. So because we're connecting to our load balancer here, we are actually routing traffic, in theory, to both of these nodes in our cluster. Or if we had maybe 5 master nodes in our cluster, then all of those would be registered with our target group here, and the load balancer would be responsible for forwarding traffic from its TCP 6443 to any of the nodes that have been registered with the target group here called CBT K8S. So now that we've got a functional cluster here with just a single node, we need to go ahead and run the command up here in order to join a secondary node into our cluster and help to ensure that it's highly available. I hope this has been informative for you, and I'd like to thank you for viewing.